Okay? Now let me show you how to find the determinant using cofactor method for a matrix, a 3 by 3 matrix. So let's say Q is equals to 2, 1, 3, 0, 3, 1, 4, 2, 0. So we are asked to find the determinant of Q. So using the second row to find the determinant of Q, hence step number 1, we find the elements in the second row for the minor of Q. We don't have to find the whole minor of Q. So we just focus our attention to the second row. Second row here, 0, 3, 1. In order to find the first element here, at row 2, column 1, as I said just now, we circle the element at location row 2, column 1, then draw a line which represents the row that passes through this element, and another line that represents the column that passes through this element. So we cut off these two, the rows and column. So what remains is 1, 3, 2, 0. In order to find the minor of this element, we use the cross multiplication method. So in this case, we have 1 times 0, we write down 1 times 0, minus 2 times 3, 2 times 3. So equals to 0 minus 6. So the answer is negative 6. That means the element of a minor for Q at this location 2, 1 will be equals to negative 6. So next we have to repeat for the second element in row 2 and third element in row 2 as well. So for the second element, we have row 2, column 2, circle row 2, column 2, draw the row line and the column line. So what remains is 2, 0, 3, 4. We cross multiply 2, 0 and then 4, 3. So the answer is 2 times 0 will become 0. 4 times 3, 4 times 3 equals to 12. Then 0 minus 12 will give us negative 12. So that is the second element of the minor of Q. Next, the third element, row 2, column 3. Circle the element at row 2 and column 3. So we have 2 times 2. Alright, 2 times 2 minus 4 times 1. So 4 times 1. So the answer is 2 times 2 equals to 4. 4 times 1 equals to 4. 4 minus 4 equals to 0. So we have all the three elements of the minor of Q. So next step is to find the elements in the second row of cofactor Q using the formula, right? A, 2, 1. That means the element, the first element in row 2, which is at row 2, column 1. So we will take the minor of at this location, which is negative 6, times negative 1 to the power of 2 plus 1, which we get it from here, 2 plus 1. Alright? So the answer will be negative 6 and negative 1 to the power of odd number. 2 plus 1 is 3, which is odd. So the negative will remain as negative 1. So negative 1 times negative 6 is 6. And then for the second element, which is negative 12 just now. So negative 12 times the formula negative 1 to the power 2. 2 means you write 2 plus 2. So from here, since 2 plus 2 is 4, which is an even number, so negative will become positive. So we have 1 times negative 12 equals to negative 12. And finally, for the third element, 2, 3, so we will take back the third element of minor, which is 0. So 0 times negative 1 to the power 2 plus 3, which we get it from here. 2 and 3, so 2 plus 3. So 2 plus 3 is an odd number. So odd number power, negative will retain. So negative 1 times 0 equals to 0. So from here, we will now proceed to find the determinant of Q. So as I said earlier, determinant is equals to the product of elements in the original matrix and the elements of cofactor in that row, same row. So we have the matrix Q just now. So we take the original matrix in row 2, which is 0, 3, 1, and then this is the cofactor in row 2. Alright? So we take the first element 0 times 6, and then 3 times negative 12, and 1 times 0. So we will get determinant equal to 0 times 6 here plus 3 times negative 12 plus 1 times 0. Alright? So the answer is 0 plus negative 36 plus 0 equals to negative 36.